Welcome to another one of my videos for the SAT reading section, and in this video we're going to be looking at data passage questions. Primarily we're going to look at how we answer those kind of questions that come in your data passages or the passages with graphs. So we're going to look at the factual understanding required to answer these questions and how do you read graphs in general. The latter being quite general, so you'll be able to apply it beyond your SAT as well. They're just going to be simple reading tips, very simple basic details. I'm just going to cover it because there is quite a bit of emphasis, although I suppose most of you probably already know how to do that. In terms of factual understanding, as you're reading the passage, make a mental note of the conjectures, so what they're predicting. Look for the evidence that they collect for or against it. Are there any other findings, any other possible investigations they can think of after they obtain the results? Now, also try looking at, if they mention it, what the previous data suggested, what they thought before this investigation, and why it was challenged. So what made them do this experiment, or what led to a change of opinion if there was one. If they're explaining a certain phenomena, understand the phenomena detail by detail. Not detail by detail, but understand the phenomena in general. Are there certain exceptions for when the phenomena works or doesn't work, or when it works in a different way? Are there special cases? And understand what is being talked about, and therefore understand what is irrelevant, because many times you'll have options that are irrelevant that seem relevant and might be tempting to select but are actually not being talked about in the passage. So this makes it easy when you're proceeding by elimination if you know that was definitely not talked about in the passage. So that's pretty much all the factual understanding you need. The questions in your database questions tend to be very, very explicit. So long as you've read the passage, you're definitely getting all your marks in that. Now, how to read graphs. This once again is going to be, as I said earlier, very basic tutorial, and it's something most of you probably already know because the database questions are one of the scoring points, one of the scoring places in your SAT, but here we go. Bar graphs, I like to describe them as coming in two types, either they're composite or single. A quick note over here that the orientation of the graph does not matter, so whether it's horizontal or vertical, it does not make a difference in terms of answering the questions, and it really doesn't in all cases for your SATs. So this is what I like calling single, so we're only looking at one type of projection, so there is only one series in the graph. So you need to look at which axis has labels, so that are your labels essentially, and the other side is measuring was giving you the numeric values. So how you read this is solar is at 2. If it's in between 4 and 6, it means 5. If it was somewhere around here where my mouse is moving, it would be 5.5. So you make approximations if the axis does not show you exactly where it is, and you need to understand what the chart is showing you principally when you see a chart. So it's saying price projections in 10 years. There is current price, and then presumably the other 3 are showing how much electricity generated from these would cost in the next 10 years. These are very vague bar charts, and the other charts that I've generated are all very vague, and they're just simply meant to show you how to read them, and I did not testify or say any of this data is factual. They're random values, random examples. So the questions they may ask you is so if the passage is about energy conservation, they may ask you how does the data show that solar power will be the best for consumers in 10 years? Best for consumers in 10 years, aka the cheapest in 10 years. So solar power is $2, and so you'd select the option that it shows solar power is the cheapest within the 10 years, half the current price, and therefore the report, sorry about that, might also ask about the report. In your essay, they may talk, in your passage, they may talk about maybe a projection for a shift towards nuclear power in the coming years, right? Although the general trend in the real world is that the percentage of electricity produced by nuclear power is expected to decrease. For the sake of the report and for the sake of this question, let's assume that the report in the passage you're reading says there will be a shift towards an increase in nuclear power, for generating electricity. So what can be anticipated about the future prices. So we see that the current prices is 4, but nuclear prices in the predictions in 10 years show is at 10. So what can be anticipated about future energy prices? If nuclear power produces a greater percentage of our energy prices will rise. So you'll have to link back to your passage and use the chart to see how it supports or refutes a particular claim. That's the point of these charts. Now this is what I like to call a composite bar chart. So these have different series. It's showing data for company A, company B, and company C. We look at which one has labels. So this is the one that has labels, and this one has percentage. And generally, when you have one bar divided into 3 parts, it is in terms of percentage. So the measurements are in terms of percentage. So how do you measure percentage share for, let's say, the second or the third element or the first element? The first element is pretty simple. Look at where it goes until it's about 49 over here. So that's 49% minus 0%. Now for company B for steel, this is around 76%, this is around 49%, so that is 27%, and that is 100 minus where it ends over here, so that's 76, so 24%. So what you do is measure where the section of the composite bar ends and where it starts. The difference between that is the percentage share. And understanding what the chart is showing us here, we are looking at the title is very indicative of this. So we're looking at the market share of 3 companies in different metals, right? So you may have very explicit questions like what percentage of the steel industry is serviced by company B? So 76 minus 49, 27%. It may be a company's. So your question will not explicitly give you material, but your passage may be talking about when a company is known as a monopoly. So it may say that, okay, the definition of a monopoly, very accepted definition, is that if 40% of a market is under a particular company, that market is characterized as a monopoly, right? So they may just ask a question like, which company is a monopoly in the most number of markets? Now, if we look at nickel, company C is the monopoly. It has around 41%, 100 minus 59, so 41% of the market. If you look at solder, about 42% of the market is under company A. If we look at aluminum, so that's about 76 and 28. So about 48% of the market is held by company B, and in the steel market about 49% of it is held by company A. So we see in 2 markets company A is a monopoly, and therefore the answer to this question is company A, as it is a monopoly in 2 out of the 4 markets. Now given so your passage may also explicitly give you this information saying that, okay, company A is a monopoly in these 2 markets, and it may ask why it may ask about what the chart does not address, or you may have an option referring to what it doesn't address. So if you had an option saying that company A makes the most revenue, what you need to recognize is that unless your passage explicitly says so, the bar chart does not have any way of telling you that, because it just shows percentage of market share. In order to determine revenue, we need to know the price of each of these metals that are not given. So therefore, if any option talks about revenue and there is no explicit mention of revenue in the passage, you cannot deduce that from the chart. So why I've included the third one is it's very important to understand what is actually being displayed by the chart and what is not. Now, this is another type of composite bar chart. So this shows you actual numerical values, and if you want to know how much more one company is selling than the other, you can just subtract. If I want to know how much more solder is company A selling than company C, so company A is selling roughly 3,500 tons, if I can see, and company company C is selling about 3,000 tons, so I'd say 500 tons of solder. So that's how you just read these. When you have charts like these, a composite chart like this, it is generally showing numerical values. In pie charts, it is once again a chart that shows proportions. So you need to understand that the pie chart shows you proportion and not quantity. So while I can conclude that a greater person that the company sold more in the first quarter than other 3 quarters combined, I cannot exactly conclude how much more it sold. I can say roughly 22% of its sales took place in quarter 2, but I cannot say what value that is. I can say quarter 3 and quarter 4 had reasonably similar amount of sales, but I cannot say what that was. So I can say the proportion, and I can measure relativeness, relative sales amongst the two, but I cannot exactly say how much or what the difference was. And pie charts, it's very important to understand that they only can display proportion. Venn diagrams. Now it's very important to understand what each of these three means. Now if you have two places that intersect, they share common grounds at the points where they intersect, but they also have distinct elements represented by the parts where they do not intersect. If it is two completely separated circles or ovals, based on what how the Venn diagram looks, they're completely distinct elements. If one is inside the other, that means whatever that means if the yellow is element B and red is group A, we could say element B is a part of group A, right? So it's just very simple theory. When you look at the Venn diagram, you just need to understand what is in what, and what simple diagrammatic representations mean in order to understand the graph. Line graphs are pretty similar to bar charts, where we generally use where we need to show continuous data, so between two variables. So here maybe we're looking at the concentration of a substance versus the temperature of a substance. When we want to look at a pattern, so there may be questions about pattern or anything that stands out. So they may ask you a question about at which temperature is the concentration of whatever is being shown the lowest. So concentration of orange the lowest, you would have to point out 20, and you may have an anomalous point. So they may ask you about that. So when you're looking at a line chart, you're looking at the patterns, and if anything stands out, if there's a sudden slump, if there's a sudden decrease, the minimum points, the maximum points, those are the things you're looking for, yeah? And the other kinds of things that they have seen them asking is tables. Now I'm not going to cover how to read a table, because you just look at the heading and what comes under it. It is very easy to read a table, but just so you know, tables also do come in terms of data. And there are other types of charts. There will be slight variations in terms, there may be a bar chart, but with slight differences. I mean, I cannot show you an example, but you will encounter them. My point of putting this is that the methods of reading them still do not change. If it looks like a bar chart, you read it like a bar chart. If it looks like a line chart, you read it like a line chart. And with that, in the next video, we're going to be looking at paired questions. So often you'll get sets of questions where they'll ask you what is x, and the next question will be what evidence can you find to prove your option. So there is a particularly good way to approach these questions that I'll be covering in my next video, which will probably be the final video. So till then, thank you and have a good day.